In this video, we are going to take a look at the file carving process and important concepts such as the select and allocated space and the deleted files. Next, we will cover file carving tools, that are tools to automatically recover deleted files from a disk image, such as Foremost, Scalpel and Photorec. In the first video overview of the Sleuth Kit and file system analysis, we have seen that the smallest addressable data units on file system are called blocks or clusters. They can be of different size, also depending on the file system, but generally blocks of 4 kilobytes are used. The block size is therefore the smallest disk space that a file can use. If a file is larger than the block size, then various blocks are allocated to that file, the number of blocks depending on the file size. If the file size isn't an exact multiple of the block size, the last allocated block is only partially used to store the file's data. The space left between the logical end of the file and the end of the block is called the slack space. For example, as we can see in this diagram, if a file occupies only 2 kilobytes of the last block and the block size is 4 kilobytes, it uses only the first 2 kilobytes, and the remaining 2 kilobytes of the block are unused and form the file slack space. The analysis of a slack space is important for a forensic examiner, because some tools, for example BMap on Linux, allow to hide data in a file slack space. Slack space could also contain remnants from a previously deleted file. Indeed, when a file is deleted, the relative directory entry is removed, but for example the master file table entry on Windows and the inodes on Linux still remain. Also, its allocated blocks remain intact but are marked as free, not used, and can be allocated to another file. These blocks are part of the so-called unallocated space. Unallocated space could also reside between two disk partitions and could be revealed by the MMLS tool, as we have seen in the previous section covering the Sleuth Kit. Until they are not allocated again and overwritten, the block's contents can be recovered using the Sleuth Kit tools or with specific data carving tools, as we are going to see. Data carving is the process of identifying and extracting meaningful data out of the unallocated and slack space. It is usually performed to recover these deleted files that no longer has an entry in the files table that could tell which data blocks were allocated to them. In the previous sections, we have seen that files are identifiable through the magic numbers included in the file's header. Data carving relies on locating the magic number of a certain type of file and copying all the binary data between it and the corresponding end of file marker. If the file's data are stored on contiguous blocks, then the process is straightforward. If the file is fragmented, that is, its blocks are scattered on the disk, then carving becomes more challenging. Algorithms that use heuristic techniques and can also handle files fragmentation have been developed and used in carving tools. In this video, we are first going to show how to recover deleted files from a disk image using the Sleuth Kit tools, iCut in particular. Then we are going to cover 3 tools included by default on Kali Linux, that are Foremost, Scalpel and Photorec. Before covering automated carving tools, it's useful to see an example of how to recover a deleted file using the Sleuth Kit tools. Recall from the first video of the previous section, overview of Sleuth Kit and file system analysis, that we can use the FLS tool with the D option to scan an image for deleted files. So we execute the tool on a sample image. The output shows a deleted doc file renamed after its deletion without the initial letter, and that has 5 as the master file table entry number. To have more information about this file, we can run the istat tool specifying the master file table entry. Indeed, the file is in a not allocated state, and we can see a list of all the sectors where its data reside. To recover the file, there is the iCut tool, that by default displays the contents of a file, identified by the master file table entry to the standard output. iCut has also a specific option for file recovery, that is the R option. So we execute it with this option. Specifying the master file table entry, and we redirect the output to a file, recover doc. We can then examine the file's metadata with the EXIF tool. We can see that the file is actually a Microsoft Word document, but it's titled Jimmy Jungle. Now we are going to introduce free command line carving tools included by default on Kali Linux: Foremost, Scalpel, and Photorec. All these tools carve files from raw disk sectors, on a lower level than the file system, relying on databases of headers and footers of many different types of files, and can also work directly on disk image files. To show these free tools in action, we use a sample image of a FAT32 file system expressly created for a file carving exercise, and that we can download on the Digital Forensics Tool Testing Images page. The exercise is named Basic Data Carving Test number 1, and the image is comes into a zipped file of 11 megabytes of size, and the image contains deleted files and is 62 megabytes of size. In this way, the file size is not too big, and so the carving process is fast, but on large images it can take a very long time. The first carving tool we cover is Foremost, that has been developed at the Air Force Office of Special Investigations and later updated at the Naval Postgraduate School. The default configuration file for Foremost is /etc/foremost.conf, which we usually edit only to enable the recovery of file formats not included in the default configuration, but is those that has built-in extraction function. We take a look at a foremost configuration file, and we can see that for each format the headers and footers are provided. To enable a format, we simply uncomment the corresponding line. In this case, we don't modify the foremost configuration file, and we use the default configuration. We execute the foremost on the sample test image we have downloaded. The mandatory options are O, that specify the output directory where to save the recovered files, and the I option, that specify the input file. We execute the tool. Now we give a look at the output directory, that is foremost output, and in particular at the audit.txt file that reports the extracted files. Each file is named from the starting sector number on the image, followed by the extension. The size and the starting offset in bytes are also reported. At the bottom, there is a summary of the different formats with the number of files recovered. The output directory also contains a subdirectory for each type of file with the corresponding recovered files. Now we execute foremost with the help option to see all the available options. If you want to recover only specific file formats, there is the T option, followed by the type of files separated by commas. We have already seen the I option to specify the input file. And if we don't want to save the recovered files to the disk, but simply write the audit file, we shall specify the W option. The option, the verbose option, displays the audit, also display the log messages and the audit file on the standard output. The second tool we cover is Scalpel, that is derived from Foremost. The current latest version available from Kali Linux repositories is the 1.60. The latest version is the 2.0, and the source is available at the Sleuth Kit GitHub repository. Version 2 includes interesting new features such as multithreading, also on graphic processing units, regular expression support for headers and footers, and embedded header-footer matching. Scalpel's configuration file is located at atc/scalpel/scalpel.conf, and it's very similar to that of Foremost. The difference is that we first have to uncomment all the lines relative to the file formats we want to enable, because there are not built-in ones. In this case, we use a configuration file with all the formats enabled. Scalpel's usage is also very similar to that of Foremost. We run the Scalpel tool on the same test image, specifying the O option for the output directory and the name of the image. Scalpel requires the output directory to be either empty or not exist. We run the tool. When the execution has completed, we give a look at the output directory. And there is, like in Foremost, the audit.txt file. Looking at the audit file, we can notice that here the deleted files extracted are more than those recovered by Foremost. Indeed, Scalpel seems to report duplicate files with the same extensions and starting at the same offset. Like, for example, this file and this. The last carving tool we cover is Photorec, developed by the same developer of Test Disk. Despite its name, this utility is not only capable of recovering image files, but, like the other carving tools, can also recover many different file formats. It's more intuitive to use compared to Foremost and Scalpel, as it provides a text-based user interface like Test Disk. To execute it, we run the command Photorec and the name of the image, that is the same sample test image. It shows the textual interface with available media to analyze. We hit the Enter key on Proceed, and then select the only available partition. We could also change the program's options. Here, paranoid means that recovered files are verified and invalid files rejected, while expert mode allows us to force the file system block size and the offset. We can also change the files options if we want to modify the list of file formats to recover, checking or unchecking the corresponding boxes. Again, we use the default list. So we go back and hit the search key, and then on Other to select the FAT file system. Then we have to choose the output directory where to store the recovered files, and hit C when the destination folder is correct. The program starts scanning the image and displays the recovery progress, showing a summary with the number of recovered files when completed. The files are saved in the recoup dir subfolder, as we can see with the file manager. We take a look at this folder, and we can notice that for two documents, Photorec are also recovered the file name from the metadata. Photorec doesn't organize files in subdirectories based on their formats, like the other carving tools.